Imagine waking up one morning and discovering that a crack has ripped through your backyard, a tear in the very land you thought was solid and unchanging. Now imagine that tear stretching for thousands of miles, so wide and deep that one day it might flood with seawater and split an entire continent in two. It's not science fiction, it's happening right now. Under Africa. In 2018, a massive fissure suddenly appeared in Kenya, tearing across roads and farmland, shocking locals and scientists alike. But this wasn't just an isolated event. It was a visible sign of something much larger, a hidden process deep beneath our feet, where the Earth itself is pulling apart at an almost imperceptible speed. Beneath the sun-baked plains and ancient deserts of East Africa, unimaginable forces are at work. Rivers of molten rock move silently under the crust, reshaping the very bones of the continent. And if you could watch time unfold like a fast-forwarded movie, you would see Africa slowly splitting like a living organism undergoing an incredible transformation. But what secrets does the Earth hide beneath this ancient land? And what will the birth of a new ocean mean? Not just for Africa, but for the future of our planet. Let's dive into the hidden story under Africa's surface. In this journey beneath Africa, we're going to uncover one of the most astonishing geological events unfolding on Earth right now, a continental split in real time. You'll learn how the East African Rift is more than just a series of cracks in the ground. It's a massive ancient wound that stretches over 3,000 kilometers, slowly pulling an entire region apart. We'll explore what scientists have discovered beneath the crust, rivers of magma, hidden lakes, and enormous fault lines, and how new oceans are born in the heart of continents. But this story isn't just about the distant future. The forces reshaping Africa today will have profound effects on climate, biodiversity, human civilization, and even global shipping routes. We'll journey back in time to understand how continents have split before, creating the Atlantic Ocean and shaping the world we live in. And we'll peer forward into the distant future, where a newborn ocean might redefine maps, redraw borders, and create entirely new coastlines. Throughout this exploration, we'll reveal the hidden processes at work beneath our feet, processes that move so slowly they're invisible to our daily lives, yet powerful enough to tear a continent in two. Why does the Earth break apart? What hidden dangers and new opportunities lie ahead for Africa and the world? And how can understanding these slow, deep forces help us prepare for a planet that's constantly changing? The answers are buried deep beneath Africa's rugged surface, and they're waiting to be uncovered. Let's descend together to where continents are born, oceans are made, and the story of Earth is still being written. Before we dive into today's mystery, here's something important. Over 95% of people who watch our videos aren't subscribed to the channel. If you enjoy this type of content, support this channel by subscribing. It only takes 2 clicks for you, but it means a lot to us. It helps us grow, reach more curious minds, and build a strong community around the questions that matter. So go ahead, hit that button, and let's keep exploring together. To understand why Africa is splitting apart today, we have to go back, not just thousands, but hundreds of millions of years, to a time when the world looked nothing like it does now. Picture a giant landmass, a supercontinent called Pangaea. About 200 million years ago, all the continents we know today, Africa, South America, North America, Europe, Asia, Antarctica, and Australia, were fused together into this single colossal island, surrounded by a global ocean. It was a strange and wild world. Giant deserts stretched across the interior, and vast tropical forests hugged the coasts. Dinosaurs roamed the land, and early reptiles and amphibians thrived in the swamps. But beneath the surface, invisible to the creatures living above, the Earth's internal engine was stirring. Heat from the Earth's core was trapped under Pangaea's massive crust, causing it to bulge and crack like an overinflated balloon. Slowly, the supercontinent began to tear apart. First, small fractures appeared. Then those fractures deepened into rift valleys. And finally, as magma welled up from below, the land split, creating new oceans, like the Atlantic, and giving birth to the world's familiar continents. The Earth is restless by nature. Its crust isn't a solid shell, but a mosaic of tectonic plates, giant slabs of rock that float atop the hot, flowing mantle beneath them. These plates are constantly moving, crashing together, sliding past each other, or pulling apart, though usually at speeds slower than your fingernails grow. Sometimes the movements are violent and sudden, causing earthquakes and volcanic eruptions. Other times the changes are glacially slow, invisible on the scale of a human lifetime, but relentless over millions of years. Africa, too, has always been on the move. After Pangaea broke apart, Africa drifted into the center of the global stage. It became a mighty, stable continent, a crossroads for life, evolution, and human history. But deep beneath its crust, forces were once again building pressure. Scientists believe that around 25 to 30 million years ago, a new cycle of change quietly began. The vast African plate started to feel stress from the movement of the surrounding plates. The Arabian plate pulling away to the northeast, the Indian plate driving north into Asia, the Atlantic seafloor widening to the west. This stress didn't break Africa all at once. Instead, it weakened a scar line running through the continent, forming what we now call the East African Rift System, a network of deep cracks, valleys, and fault lines stretching from Ethiopia down through Mozambique. Imagine slowly pulling apart a piece of taffy. First, it stretches. Then small fissures form. Gradually, the rift deepens and widens until the taffy tears in two. That's exactly what's happening under Africa. Today, this rift is so massive that it can be seen from space. A vast, jagged scar slicing through deserts, savannas, and mountains. In places like Ethiopia's Afar Depression, the land has already sunk dramatically, creating vast sunken plains and strange alien landscapes. Volcanoes like Mount Nyiragongo and Mount Erta Ale constantly bubble and erupt, releasing molten rock from deep within the earth. The rift is essentially a giant, slow-motion wound, and the forces behind it have been shaping the landscape for tens of millions of years. But what exactly is driving this colossal split? One major force is the presence of a superplume, a giant upwelling of superheated rock rising from deep within the mantle under East Africa. Think of it like a colossal underground geyser of molten material, slowly pushing upward, weakening the crust above it. As the plume rises, it heats and stretches the lithosphere, the rigid outer shell of the Earth, making it thinner and more prone to cracking. Eventually, if the process continues, the rift will become so wide and deep that the Red Sea and the Indian Ocean will flood into it, creating a brand new ocean where once there was dry land. Some scientists estimate that in 5 to 10 million years, a piece of Africa, including Ethiopia, Somalia, Kenya, Tanzania, and Mozambique, could separate entirely, drifting off as a new continental island. It's hard to comprehend changes on such vast timescales. To humans, continents seem eternal and immovable. But in the grand story of Earth's history, they are fleeting, ever-changing characters, rising, breaking, drifting, and colliding, like actors on a shifting stage. Africa's Great Rift is simply the next act in a play that has been going on for billions of years. And as we'll see next, the changes happening deep beneath Africa's surface today could have consequences far beyond its borders, reshaping the world for millions of years to come. How does a continent split? When you think of land breaking apart, you might imagine sudden earthquakes or explosive volcanoes. But the splitting of a continent is a slow, persistent process, one that takes millions of years, driven by immense forces far beneath the surface. At the heart of it all is tectonic tension. The Earth's lithosphere, its outer shell, is not a single piece, but a puzzle of plates that drift atop the softer, flowing asthenosphere beneath them. Where these plates pull apart, the crust stretches and thins, much like taffy being gently but persistently pulled. Over time, this thinning becomes critical. Cracks form. Molten rock from the mantle wells up into these cracks, creating volcanic activity and further pushing the plates apart. Eventually, the cracks grow into full rift valleys, and those valleys can deepen into basins that may one day be submerged by oceans. This is what's happening along the East African Rift System today. What's happening beneath East Africa? Right now, beneath the surface of East Africa, a massive mantle plume, a rising column of superheated rock, is creating extraordinary stress on the lithosphere above. This plume is believed to be one of the largest and most powerful on Earth today. It acts like an invisible hand, pushing up the land from below. This upward pressure weakens the crust, causing it to stretch, crack, and eventually split. Scientists have identified two major branches of the East African Rift: the Eastern Rift, running through Ethiopia, Kenya, and Tanzania; the Western Rift, stretching along the borders of Uganda, Rwanda, Burundi, and the Democratic Republic of Congo. Between these rift branches lies a rising bulge, the Kenya Dome, lifted by the immense heat and pressure from below. The surface evidence is everywhere: deep valleys carved into the landscape, volcanoes like Oldoño Lengai, the only volcano known to erupt carbonatite lava, a rare, fast-flowing form of lava; giant fissures like the one that appeared in Kenya in 2018, opening overnight across farmland and roads. But the most extraordinary changes are happening invisibly, deep beneath the crust. Seismic studies reveal that the lithosphere beneath the rift is dramatically thinner than elsewhere in Africa. In some places, it's less than 20 kilometers thick, compared to 100 kilometers or more in more stable regions. This thinning allows magma to rise more easily, further driving the rift apart. How does a new ocean form? The splitting of a continent follows a fascinating sequence, one that Earth has repeated many times before. The steps are slow but inevitable. Initial cracking. The crust stretches and fractures, forming rift valleys. Small lakes and volcanoes appear along these cracks. Thinning of the crust. The crust becomes thinner and weaker. Hot magma wells up, forming new volcanic rock along the rift. Creation of basins. As the rift deepens, basins form, long, sunken valleys. Water from rainfall or nearby seas may begin to collect here, creating lakes. Flooding by ocean waters. Eventually, if the rift continues to widen and deepen, the edges of nearby seas, such as the Red Sea or Indian Ocean, may breach the land, flooding the rift valley. New ocean formation. The rift evolves into a mid-ocean ridge, like the Mid-Atlantic Ridge, with new oceanic crust forming as magma rises and hardens. If the East African Rift continues on its current path, scientists predict that within 5 to 10 million years, a brand new ocean will cut through East Africa. Countries like Ethiopia, Kenya, and Tanzania could find their eastern parts separated by vast new waters, while the western parts of Africa remain on the original continent. Other examples: Earth's past splits. The story of the East African Rift is not unique. In fact, it's part of a long history of Earth tearing itself apart and reshaping the map. The Atlantic Ocean. Around 180 million years ago, what is now the Atlantic Ocean was just a series of rift valleys splitting apart the supercontinent Pangaea. Over millions of years, the valleys deepened, the seas flooded in, and the Atlantic grew into the vast ocean we know today. When you stand on the shores of Western Africa and look across the ocean toward South America, you're looking at the mirror image of a split that began with a rift, just like the one in East Africa today. The Red Sea. A much more recent example is the Red Sea, which formed about 30 million years ago as the Arabian Plate pulled away from Africa. The Red Sea is essentially a very young ocean, a wide, flooded rift, and offers a glimpse of what East Africa's future might look like. Initially, it started as a small crack, grew into a rift valley, and then eventually filled with seawater, forming the body of water we see today. What lies hidden beneath the rift? Beyond the visible cracks and volcanoes, scientists are uncovering a hidden world deep beneath the East African Rift. Subterranean rivers of magma. These massive flows of molten rock help drive volcanic activity and further stretch the crust. Ancient fault lines. Some faults in the rift zone are tens of millions of years old, remnants of earlier continental movements. Hidden lakes. Beneath the rift, trapped groundwater systems and deep subterranean lakes exist, playing a critical role in local ecosystems. One of the most astonishing discoveries is that life itself may have been deeply influenced by the rift. Some theories suggest that the shifting landscapes of East Africa, the formation of valleys, mountains, and lakes, created the environmental pressures that spurred the evolution of early humans. Our ancestors may have adapted to a rapidly changing environment, leading to bipedalism, larger brains, and the incredible adaptability that defines our species. In this way, the story of Africa's Great Split isn't just about geology, it's about the story of us. When we speak of continents splitting, it's easy to think only in terms of distant futures, millions of years from now. But the forces tearing Africa apart are already impacting life on the surface today. Impact on local populations' communities living along the East African Rift experience the consequences firsthand. In parts of Ethiopia, Kenya, and Tanzania, the land is literally shifting beneath their feet. Fissures open in farmland, cutting villages in half. Roads buckle and split apart. Infrastructure built over these shifting grounds, homes, schools, pipelines, is constantly at risk of damage or collapse. For rural populations who often depend on agriculture, even a small shift in the land can mean the loss of critical resources: arable land, freshwater access, and safe shelter. The sudden appearance of a giant crack in Kenya in 2018 wasn't just a geological curiosity. It was a real crisis for families whose homes were swallowed by the earth. And as the rift widens over time, relocation of entire communities might eventually become necessary. Environmental changes. The East African Rift is also reshaping ecosystems. As new valleys form and old ones sink, rivers are redirected, lakes expand or dry up, and fertile regions can turn into arid wastelands, or vice versa. Unique ecosystems, especially those relying on stable lake systems like Lake Tanganyika or Lake Malawi, are under constant pressure. Some species adapt, others vanish. In many ways, the rift acts as an unpredictable sculptor of life, both creating and destroying habitats, sometimes within a single generation. Geopolitical and economic implications. The slow birth of a new ocean could have far-reaching geopolitical effects. Imagine a future where what is now Ethiopia's lowlands or Kenya's interior are suddenly coastal regions bordering a new sea. This shift would redefine national borders, create new ports, and potentially spark conflicts over water rights, mineral resources, and maritime trade routes. Even today, exploration for geothermal energy, tapping into the immense heat rising beneath the rift, is booming. Countries like Kenya are investing heavily in geothermal plants, turning the rift's fiery underbelly into a valuable source of sustainable energy. At the same time, this geological volatility poses risks for major infrastructure projects such as railways, highways, and pipelines critical to regional development. Facing a force as immense and slow-moving as continental drift might seem impossible. How do you prepare for changes that unfold over millions of years? The answer is one step at a time, with knowledge, technology, and adaptability. Scientific monitoring. First and foremost, scientists are not just observing. They are actively monitoring the East African Rift's every move. Networks of GPS stations have been installed across the rift zone to detect even the slightest shifts in the land. Satellites equipped with radar can measure how the Earth's surface is deforming over time, with precision down to millimeters. Seismologists record the constant tiny earthquakes that ripple through the region, using them as clues to map hidden faults and magma movements deep underground. This real-time data allows scientists to predict where new cracks might open, monitor volcanic activity linked to the rift, warn local communities when dangerous shifts are imminent. Knowledge is our first line of defense. Human adaptation. On the ground, people are learning to live with the moving Earth. New infrastructure in East Africa increasingly accounts for geological risks. Roads and bridges are designed with flexible foundations that can better withstand ground shifts. Geothermal energy plants, like Kenya's Olkaria complex, tap into the Earth's heat safely without disturbing the fragile land more than necessary. Urban planning now considers rift zones as dynamic regions, not static ones. For farmers and rural communities, adaptation sometimes means more immediate action, moving to safer ground, finding new water sources, or changing farming practices to suit shifting landscapes. It's a delicate dance between human ambition and nature's slow but unstoppable rhythm. A bigger lesson. Perhaps most importantly, the East African Rift reminds us that change, even when it's measured in geological time, is a constant force on our planet. By studying these deep, hidden processes today, we better prepare for tomorrow, not just in Africa, but anywhere Earth's restless engine decides to reshape the land we call home. Beneath our feet, a hidden world is at work. Ancient forces shaping continents, carving oceans, and rewriting the face of the planet. The slow split unfolding beneath Africa reminds us of something profound. The Earth is alive. It breathes, shifts, grows, and fractures, not on human timescales, but on the vast timeline of a living, evolving world. We've journeyed through the cracks opening in Kenya's soil, descended into the magma chambers that drive the East African Rift, and looked ahead to a future where a brand new ocean might divide a continent we know today as whole. But beyond the geological drama, there's a deeper story. It's the story of resilience, of people learning to live with a moving Earth. It's the story of science, of our ability to peer into the invisible, to predict the unpredictable. And it's the story of impermanence, a reminder that nothing, not even the land beneath our feet, is truly permanent. In a world where so much seems uncertain, there's something strangely comforting about understanding Earth's deeper rhythms. We realize that change is not an anomaly. It is the natural state of things. Africa's slow split is not a catastrophe. It is a continuation of a grand, cosmic dance that has been shaping life for billions of years. A dance that gave rise to oceans, continents, mountains, and even to us. As we watch Africa's story unfold over the coming millennia, we are not merely observers, we are part of it. Tiny, fleeting beings living out our moments on the surface of a restless, beautiful world. The Earth moves, and in understanding its movements, we find our place in its endless story.